In this video, I'd like to talk about the graphs of piecewise functions. So remember with a piecewise function that it's a function that's split into multiple parts where you have these different domains giving different equations. For instance, for this f of x, between x values of minus 5 and 2, we have this downward sloping linear function. So this is the equation of a line with y-intercept of 0. And between x values of 2 and 6, but not including 2 is included in this one with the equal sign, it would just be equal to 1. So that would just be a straight line. So we need to compare that to one of these graphs. And of course, we could sketch our own picture just to get a general idea of what's going on. So we know at 2, this is where it starts this line of just 1. And we have to put a hole there because it doesn't include the point 2, and it's just a straight line all the way to the x value of 6, but we do include that point. So that's this part of the graph where it's just equal to 1 between this interval. But before that, it's a linear equation, and remember linear equations, y equals mx plus b. So our slope here is minus 2/3, and our y-intercept is 0. So we'll go through at 0, and then from there, it will go down 2 over 3, or we can go the other way. It'll go left 3 and up 2. So maybe right there, and we'll continue it. So all the way downward, and it ends at 2, but it includes that point. So we'll have a closed circle there. So basically, with your inequality, if it has the equal sign, then you'll fill in a circle. And if it doesn't have the equal sign, if it's just greater than or less than, you'll have this open circle here. So this is the general picture that we're going to be looking for. And we can see that A does not work because notice they kind of split it right here at an x value of 0. But our split point is at an x value of 2. That's where the two functions differ from each other or change. So we can move down. Let's check the other choices here. And choice B, you can see that's actually what we drew. Since it's this downward sloping linear function, notice it ends at 2, so it's on the correct interval. And anything after 2, it's at this y value of 1, which is what we expected. And you can also see, just to confirm the slope, that at an x value of 3, notice it goes through this point, and it goes down 2 and to the right 3. So it has the correct slope, and it ends at the right point, so choice B would be the correct answer here. So let's move on. And this equation, g of x, looks like we have two different linear equations, and they're separated essentially at this point -2. The bottom one includes -2, and the top one does not. So if we wanted to get a general sketch of this, so this has a slope of 1 and a y-intercept of 8, but of course it's not going to actually reach that y-intercept. And if we really want, we could plot these points, these endpoints here. So let me go all the way to -8 with this graph, and when we plug that in, we get a y value of 0. So let me change colors. So that would be right here, and it includes that point. Now we could also plug in -2. That gives us a y value of 6. So 1, 2, 3, 4, 5, 6 are right there. And at -2, we have to have an open circle because it doesn't include that point. And now we can connect these since it's just a line. And we can do the same thing for this bottom function. It has a slope of -1/2 and a y-intercept of 8. If you rearrange the order, it might be more obvious than it's in slope-intercept form. So when we plug in -2 to this function, we get -2 times -1/2. So it'd be a positive number. 2 divided by 2 is 1. And so we get 1 plus 8, which is at 9. So I need one more tick there. So at -2, 9. And then it's going to go through at a y-intercept of 8. So that would be this point. 1, 2, 3, 4, 5, 6, 7, 8. And we can also plug in this other endpoint of 6. So we have 6 times -1/2, that's -3, plus 8, which would be 5. So let me put in 6 dash marks here, and we go all the way up to 5. So something like that. And of course, we can now connect these with a line. And notice we had these closed circles because we included the endpoints. We had the equal signs. And for this one, we had an open circle for this top function because it didn't include -2. So now we need to figure out which of our graphs is correct. And they both look fairly similar. But first, notice the cutoff points. So at -2, and that looks to be the same in each. And it's supposed to go through at 8. This one does not go through directly at 8. Also, we know when we plug in 6 to that second one, it should be a y value of 5, which you get right here. But here, you get a y value of 4. So this is at 6, 4, which is not a part of the graph. So this is a very subtle difference. You got to be careful. And that's why I would recommend maybe drawing a quick sketch yourself and plugging in those endpoints on your interval to just see what the line should look like, or what points should be on each of these lines. So it looks like choice A in this case is correct. And let's keep going. So we have a similar situation here. Let me draw a coordinate axes. And we'll do the top equation of the piecewise function first, and I'll do it in green. So basically, I'm just going to plug in these x values on the interval. And both -6 and -1 are included in this part of the domain and will be a part of this line here. So if I plug in -6, then -6 plus 2 is -4. So we have 1, 2, 3, 4, 5, 6, and down at 4. And again, it's going to include that point. Actually, I think I drew that at 5, so let me redraw that because we're going to be at 4, or -4. And if we plug in -1, -1 plus 2 would be +1. So that would be right here. And again, those endpoints are included because we have the equal sign, so we can just connect them with a line. And let's do the other one. I'll do that in orange. We'll plug in -1 first. So 6 minus -1 would be 6 plus 1, which is 7. So at -1, we're all the way up at 7. So 3, 4, 5, 6, 7 right here. And that one's an open circle because notice it's just greater than -1, but it doesn't include it. The function already has -1 included in the top part, and it can't be both because remember with a function that for every x value, there is only one y value. So if both of these were filled in, then that would fail the vertical line test. You would have two output values for the same input value, and it wouldn't be a function. Now we can also plug in the endpoint x equals 4, and that one is included. So we have 6 minus 4, which is just 2. So we go over to 4 and then up to 2 right there. And let's connect these with a line. And that gives us our rough sketch of what's going on. And so now we just need to determine which of these graphs would match up with what we drew. And again, you want to be comfortable plugging in those endpoints. So notice this point down here for our graph in green, that was at -6, -4, and it ended at -1, 1. So we definitely need that to be a part of the graph, and it looks to be correct there and here. So that one's right so far on the bottom part. Now this one isn't right. And actually, we could have just went with the domain because the split point is at -1, and this one's at 0. So you can tell right away that this one's wrong because it's splitting at the wrong point. If it was at 0, then this would be 0 and that would be 0, but it's not. And we could double check even further. We could plot our endpoints for this orange one. Remember, this was at -1, 7, and this point was at 4, 2. But choice A would be the correct answer here.